Welcome to the lesson on T cells. Due to our lockdown drill, you need to pick up where we left off in class. Hopefully we got pretty far. And then after we finish the lesson, you need to answer the guided questions for homework. So we've talked yesterday about the B cells and how the B cells float through the bloodstream looking for antigens, whether they're bacterial or viral. But if a virus or bacteria gets into cells or hides in your cells, it can't be seen by B cells. So cells that have been already infected with viruses or bacteria, that's the job of the killer T cells to get them to sort of find the virus or bacteria that's hiding in the cells. So today, the purpose of today's lesson is to sort of see how the T cells do this. Okay. So, important for the T cells is that almost every cell has on it these major histocompatibility proteins located on their cell membrane. And then what they do is they carry or they take bits of things that are in the cytoplasm and display them on the cell membrane. It sort of gives, as it says here, a snapshot of what's in the cell or what's going on in the cell. And it allows the cell to be labeled either as self or not self. So the MHC proteins, they carry sort of particles of things that have been in the cell, whether they've been digested or not. So MHC proteins carry pieces of sort of perhaps the pathogen that's been ingested or taken in on the cell surface. And this cell, when it's presenting an antigen or a foreign particle, is called an antigen-presenting cell, or APC. Often macrophages, which we learned about yesterday, that engulf particles and digest them in the lysosome, serve as APC, or antigen-presenting cells. So here, we have a cell that's been infected by a virus, and it's displaying the particles that are inside it on its MHC proteins. And the black one here is a particle from a virus or a bacteria. Now what we're going to learn in the next coming slides is that it's the helper T cell that looks around and sort of tests these MHC proteins to see if they're sort of if they're binding to self proteins or foreign proteins. And if it's a foreign protein, it sort of sets off a cascade of activation. So T cells, unlike B cells, they attack pathogens hiding in infected cells. And they recognize antigen fragments. And this allows it to defend against also non-self body cells as well. So cells that are in your body that are not yours. So an example is sometimes, and they've been doing this a lot actually, in cancer treatments, they've been sort of seeing that T cells are able to attack in some cases cancer cells and kill them. Also, if you get an organ transplant, a lot of times, or the organ can be rejected because the body or the T cells see these cells as non-self cells and begin to attack them. When you get organ transplants, a lot of the times you take immunosuppressants to prevent this from happening. So there are three types of T cells. We have helper T cells, and their job is to alert the rest of the immune system. Then we have killer, also known as cytotoxic T cells, and their job is to attack infected body cells, so cells that are infected with a virus or bacteria. And then we have memory T cells, which stick around after the infection is over, so that once again you have long-term immunity and can respond faster to a pathogen that you've already been infected with. So this picture here, which is complicated, shows the T cell response. So here we have an anaphase presenting cell or a macrophage that has engulfed a foreign particle here, and it's displaying the virus particle that it's digested on an MHC protein. Helper cells, just like helper T cells, just like B cells, have to learn or have these different sort of what we want to call, I guess, proteins in the membrane that have a unique binding site for specific antigens. Sort of the same thing with B cells and antibodies that we discussed. So, when a helper T cell can successfully bind to the antigen, it gets activated and releases interleukin 1. Okay, that causes the helper T cells to divide and clone themselves. These clones release interleukin 2. Interleukin 2 activates the killer T cells, which we're going to talk about what they do, and it also stimulates or activates the B cells and the antibodies to do their attack. Then, after sort of the infection is over, okay, you also get the production of memory T cells. Which can then, of course, respond to the infection faster. So, what I just explained, you're now going to write on that empty slide. Instead of writing, because I don't feel like writing all that with a mouse, I'm going to type it. Okay, so here we are in the empty slide. So in the first part of the T cell response is that a macrophage displays a, I would say, antigen particle. An antigen particle on the surface of the membrane using the MHC proteins. When it does it, it's called the APC, or the antigen promoting complex. Then helper T cells, specific helper T cells, bind to that antigen and get activated. Okay, this causes them to release interleukin 1. Which causes the helper T cells to divide, and what that's called creating clones. These clones, so the clones per se, release interleukin 2, and then interleukin 2 activates the killer T cells and B cells, which can make antibodies and sort of trap more of the antigens that are just located swimming around in the cell. So you can write that in there. So now the question is, once the T cells are activated, the killer T cells are activated, what do? So they, just like the helper T cells, have a, and let me get the pen back out. They, like the helper T cells, have receptors that recognize specific antigens, and they bind to the cell that's infected, and using a protein known as porphyrin, puncture the cell membrane. That causes the cell to kill itself, it lyses it, and it causes the cell to complete apoptosis. Now, a lot of times you're destroying your healthy cells, because your healthy cells are infected, and we don't want the virus to be replicating in your healthy cell. So you're sort of sacrificing your healthy cells, or the cells that are infected, the cells that are infected, to sort of save the rest of your cells, and prevent maybe more virus particles from being made in a cell by killing it. So you're sort of sacrificing yourself for the greater good of the body. So this is a sort of an example of antigens and antibodies. So we've talked about blood type before. A person who has blood type A has A antigens in the blood, but B antibodies. Okay, person who has B type blood B has B antigens and A antibodies. Okay, and the person who has AB blood has both antigens, so A/B, and I can't write with this damn mouse, and then it has no antibodies. And then a person who has O blood has 0 antigens, and then it has A and B. So, if you're going to give someone with an A blood type, someone has a B blood type, what would happen is the A antibodies in the B blood would start attacking the antigens on the blood cells, and we don't want that to happen. So it's important that you stay within your blood type when you're getting a transfusion or if you're getting organs, otherwise the cells will be attacked by your immune system. So a person with A type blood can be given type A or type O. O has no antigen, so it won't be attacked by the antibodies in the blood. But it's important that you stay within your donation status, who can give it to you, so that you don't have your immune system attack the cells that you're getting from someone else. And this all appears. So, wonderful. So this is sort of the summary slide. And I went too far. So macrophages ingest particles and display them on the MHC proteins, as I try to write MHC and I fail. And then that alerts, or the helper T cells bind to those MHC proteins that are displaying the antigen, and they alert the B cells and the T cells, or the killer T cells. The B cells then can produce antibodies, which can sort of handcuff the antigen in the blood and signal for more macrophages to come. And then the cytotoxic T cells here, they can kill infected cells so that the viruses can't use the cell to replicate more viruses. And at the end of the response, there are both plasma B cells, there are both memory B cells and memory T cells. And they give you long-term immunity so that if you get the same infection again, you'll be able to fight it off faster in the secondary immune response. HIV is a virus that infects helper T cells. So if you kill the helper T cells, the entire immune system won't be activated. Because if you go back to this picture here, if I can go back, the helper T cells are responsible for activating both parts of the immune system. If they're killed, then the immune system won't be activated, and there'll be no or very little immune response. No one dies from HIV just because they have HIV. People who die from HIV get killed by other infections that are common in AIDS patients because their immune system that would normally be fighting them can't. Pneumonia is common, but they usually die from other diseases because their immune system is suppressed. And then how to protect yourself. Condom man. Moving on. So, autoimmune diseases are when the immune system attacks cells that it shouldn't. So instead of usually the immune cells only when they bond to foreign antigens they start attacking. But in many cases with these diseases they bind to cells that are a self and they inappropriately attack them. So ones we've talked about, rheumatoid arthritis causes antibodies to start attacking bone and cartilage in your joints. Diabetes, which we talked about, immune cells start attacking the beta cells, and then if beta cells can't make insulin. And then multiple sclerosis, the T cells attack the myelin sheath of the nerve cell, and that prevents it from not being able to send the action potential as efficiently as it normally can with the myelin sheath cell, with insulates the neuron. And then we have allergies. Poor Alex is a sort of overreaction to pollen. So your body all of a sudden has this huge immune response to pollen, causing you to feel drowsy and tired and sick. Drowsy. Poor Alex. All right. So I hope we're done. Now you need to answer the guided questions, and I'll see you guys tomorrow.